Welcome. I'm Pete Wolf, a retired senior meteorologist after a long career with the National Weather Service. This short video will describe an educational initiative that focuses on a key step in the warning program called threat confirmation and its role in protecting life and property when official warnings are received. To this end, I designed the Radar Interpretation of Storm Hazards course for the public to teach them how to utilize real-time radar imagery, available free through an online site or smartphone app, to recognize when their location is actually in imminent danger and to reduce the impact of false alarms, which are common with government warnings. As someone who is now stricken with stage 4 cancer, this initiative has new meaning, something I want to use to support cancer treatment, especially for children. It's a horrible, unfair disease. Course fees will support a new charitable foundation in this effort. I don't want you to donate to charity. I want you to learn for charity and gain a beneficial skill that could protect you and your family someday. When you receive an official weather warning, be it by a phone alert, a crawl at the bottom of the TV screen, or perhaps a social media image, something is missing. Warnings cover hundreds of square miles of territory and last for 30 to 60 minutes. No information is given about if and when your specific location is in danger. Is it now? In 30 minutes? Or perhaps not at all? Because of this, government warnings are not designed to directly protect life and property, only to provide an initial alert of a potential hazard. The real life protecting step in the warning process is the next one, called threat confirmation. This is where people seek information about the level of threat for their location, be it to look outside or look on TV for broadcast coverage. On the warning image to the right, we cannot tell who is in danger of a tornado within the red shaded warning area. When a warning is issued, we don't want people to make immediate decisions based solely on the warning, be it to rush to protective shelter or to just ignore the warning due to the problem of false alarms. Threat confirmation is critical to making the right decision and reducing the impact of false alarms. There's imagery from a really cool technology that you can access for free that can help with this: Doppler radar. Here's a great example. We have a large tornado warning area shown in maroon color, covering a portion of multiple counties. The warning tells everyone within the maroon polygon to take cover now, but we can do better than this through Doppler radar imagery. Here we see a storm producing a big tornado that is tracking northeast as given by the white arrow, which shows a 15-minute motion. If you live in the town of Rives, shown as point A on the image, you are directly in the path of the hazard and immediate protective action is needed. If instead you lived in the town of Haiti, point B, protective action is not needed now because the hazard is likely at least 30 minutes away. The storm could weaken or change its direction of motion slightly, sparing Haiti. People in that town simply need to closely monitor the hazard and be ready to act if needed. Finally, if you lived in Blytheville, point C, you would not be in danger at all, despite being in the tornado warning area. We have 3 different results, all within a warning area where you're told to take cover now. See how radar imagery can help you make better decisions and reduce the impact of false alarms. Radar can be beneficial even before warnings are issued. Flash flood warnings are typically issued once enough heavy rain has fallen to initiate serious flooding. On this interesting animation, let's say you live in Cantonville, marked by the white X. It's been raining heavily for an hour, but there are no warnings yet. The red shade on radar indicates where we have very heavy rain falling. Can you see an indication of continued heavy rainfall for Cantonville at the end of the animation that could yield a flood threat soon, if not already? Warnings are often late, and sometimes hazards are missed. NOAA Weather Radio is a common tool for receiving warning alerts and information. But how does this technology compare to real-time radar imagery when it comes to determining the threat level and timing for your location? They are quite different. Weather radio provides an initial alert over an entire warning area, which can be hundreds of square miles, while radar can focus on threat confirmation for a given location. Radar can be useful for providing severe and non-severe weather information, while weather radio offers less value for non-severe information. Weather radio costs about $30 to own, while radar imagery is free online or through smartphone apps. This video will describe a unique amateur-level course that teaches radar imagery interpretation for half of the cost of a weather radio. Real-time radar imagery is free to access, online or through smartphone apps. An example is an app that comes from the Weather Channel, and you'll note over 100 million downloads. You don't need to be a meteorologist to interpret radar imagery. It's a skill, just like learning how to cook or drive, requiring knowledge and practice. How can you easily get both? Online, you can find many sources of radar imagery interpretation information, with most being small subtopics of this. More complete options come in the form of university courses, which can be a bit too technical for the general public and can be expensive. For a complete online resource, provided at an amateur level that is self-study and provided at minimal cost, I offer the Radar Interpretation of Storm Hazards course. Designed by a meteorologist with 35 years of experience in radar imagery interpretation and the design of meteorologist training on the subject. It is just 2 hours long, consisting of 3 40 to 45 minute videos that you complete on your own time, with short breaks between each video. It's called a power course because it gives you the skill and thus the power to make better decisions when you receive a government weather warning that includes your area. Such training needs to describe not only how radar works, but also how it does not work, the issues associated with radar, as well as describing the key products that radar produces. This is offered in the first video. It needs to describe the key signatures to look for that are associated with each storm hazard, be it tornado, hail, damaging winds, flash flooding, and winter storms, which is offered in the second video. Finally, after providing the required knowledge, it needs to provide opportunities for students to practice. The third video ends with a short bonus section that describes some radar imagery sources, both online and through smartphone apps. Here's what the course website looks like, which you'll access after paying the small course fee. You simply complete the course videos consecutively from top to bottom. That's it. The course is designed in a manner that allows you to complete it on your schedule and to go back and review any part of it more than once. It incorporates numerous examples and exercises to give you practice in what the course teaches. The course will only be available in your area during your state's Severe Weather Awareness Week, the weekend prior to it, and the weekend right after it. You can look up the dates for your state online in early 2026. So for your next Severe Weather Awareness Week, you are strongly encouraged to complete the Radar Interpretation of Storm Hazards course. And during severe storm, hurricane, flood, and winter storm events, utilize real-time radar imagery to make more accurate and timely decisions to take protective action when in imminent danger, and not take action when not in danger. Gain the power to protect yourself and your family while reducing the impact of warning false alarms through the help of real-time radar imagery. This course will show you how. Thank you.